Hello, I was explaining at some point that strings are immutable, meaning once you declare one, it can no longer be directly modified. And when you do operations like concatenation or call methods like substring, toUpper, replace, etc., all of them create a new string, meaning a new value is stored in memory, while the original one, if it's no longer used, it's automatically deleted. And this has many advantages, but of course comes at a performance cost. In C#, unlike other languages such as C and C++, you don't have to worry about manually deleting variable values that you no longer need. There is a special construct for that called the garbage collector, acronymed GC, that automatically deletes and cleans up any unused resources. And we will discuss about the garbage collector at length on this channel in future videos. But for now, just know that while yes, it is nice to have someone automatically clean up after you, this comes at a performance penalty, of course, because every time the garbage collector needs to reclaim unused resources, it needs to pause the entire execution of the program. So no processing is done at all, because it needs to freeze anything to figure it out what resources are still in use and what are not, what can be reclaimed. And because of that, we need to learn to be efficient with the memory such that the garbage collector doesn't have to reclaim unused resources too often. So let's see just how much of a problem is inefficient usage of memory. Let's concatenate all the numbers from 0 to 200,000 in some string, and the usual way to do that would be this. We haven't learned about datetime now, but basically is the way to print the current time on the console. So we print the current time, then we declare a string, then we concatenate it a bunch of time inside the for loop, then we print the first 1024 characters from it, because it will be a very long string, so we basically print just the start of it. Then we print the current time again, so between the end time and the start time we can tell how long it took for the loop to finish. But you have to understand something. When we are at the 10,000th iteration, this string will already be very long. And I already said that when we do concatenation, so we need to concatenate the control variable I. When we do concatenation, the old value of the string is taken and it's concatenated with the new value, and the resulting string is placed in a new memory cell, which means the next cycle this loop runs, the old value of the string needs to be taken again, concatenated with the value of I, put in a new memory cell. And this happens every single cycle. For 200,000 times, it takes the old string, puts it in a new memory. So that means that the longer this loop runs, the longer this string becomes, and the more memory you need to copy every single iteration, which means the garbage collection will be out of the charts. The garbage collector will just go berserk. So I will not make you sit through the entire process. It will be a very long and painful to watch one, but I want you to notice something. Do you see this yellow tick here that says garbage collection? Well, every single tick, yellow tick that you see here, is basically the garbage collector pausing the program to reclaim unused resources. And when you see continuous yellow like this, that means garbage collection after garbage collection after garbage collection. Basically, your program is more paused than executing at this point. And when you see this, you either put gas on it, you take a flamethrower and you set it on fire and you run, or you delete everything and start from scratch. You redesign your program. So it took 50 seconds for it to complete. And in 2025, to make your users wait for 50 seconds for some processing, you better have a good reason for it. And concatenation is not one. I don't have the greatest CPU on the planet, but I have a Ryzen 9 7950X with 16 cores CPU. So even though this runs in a virtual machine, 50 seconds in CPU time is basically forever. So there is no reason. So the whole point of this example was for you to understand that just by manipulating strings, you can easily nail the performance of your program. Instead, you should be using something called a string builder like this. And again, we print the current time at the program startup and end. And we don't declare a string, we declare a string builder, which is a class. We will learn about classes in 2 lessons. But for now, just know that we use the append method to basically do what we were doing with the string. Append basically takes the new value and adds it, concatenates it at the end of the old one. So we basically do what we were doing before, just in a more efficient way, because obviously this is more efficient, otherwise I wouldn't mention it. But how much efficient do you think this would be as opposed to the old concatenation of raw strings? Well, let's see. Done. In fact, it's so fast, it's in the order of milliseconds. For the 200,000 iterations, it finishes in a few milliseconds. That's how performant StringBuilder can be. So get yourself used to use StringBuilder when you do a bunch of string manipulation. It will save your program. Now, don't go around changing every single concatenation with a string builder in your application, because it doesn't make sense to do so. You would only do so when the performance of your application starts suffering. So get also used to looking at diagnostic tools to notice garbage collections and etc. That was it for today. So if you like what you saw, express that by pressing the like button and maybe the subscribe button too if you want to see more videos like this. In the next lesson, we will talk about casting and type conversion, because sometimes you want to take a data type and convert it into another data type. For now, thanks for watching, and I'll see you in the next stack frame.